So this is the buoyancy practical session as I promised. So you can see the kerosene in a beaker, water in another beaker, and the spring balance is there. And you see it's calibrated to 0. One side is measured in Newton and the other in grams. We're going to focus on the side that is in Newton. So remember, W1 is the weight of the mass, or the weight of the object in air, which we've done that, and you see it reads 1 Newton. So we're going to make a table and record that. So 1 Newton for the 50 mass weight. And then we're going to immerse this 50 gram, this first object, in water first and check the new reading. We're going to see that the reading will reduce. It won't be 1 again. It's now a little less than 1, which means upthrust is in effect. So we record the reading, which is 0.87 when immersed in water. Remember, this is still the same 50 gram weight. Now we're going to do the same thing, but now put it in kerosene. Immerse it in kerosene. Remember to clean the mass before immersing in different fluids. So if we then dip it in kerosene and check the measure, we'll see it's also a slightly different measurement from when it was immersed in water. So as you can see, all right, the reading or the value when it's immersed in the kerosene is 0.9 Newton. We're going to do the same thing. Keep adding 50 gram weight to the weight we used initially. So this was 50 we just used. We're going to add another 50 gram weight to this other 50 to make it 100. And so remember, we repeat the same procedure. Measure the weight of the object in air, which we've done. So you see this one is 2 Newton. So the same procedure, you measure the object in air and then immerse it in the 2 liquids, one water and the other the kerosene. So the weight is then measured in water when immersed in water, completely in water. So you see it's less than 2 now. It's not like when it was in air. So we're going to record that because we're going to use it in our graph. We record it and the value is 1.73. So this 1.73 is the weight of this 100 gram mass when immersed completely in water. And we'll wipe the water off because we're going to immerse it in the kerosene now. So the question is, what happens to the value when we fully immerse it in kerosene and not water this time? So we do that and we see a slight change also from that of when it was immersed in water. So we have this time 1.8 Newton when immersed in kerosene. So you see, it's a quite simple experiment. You just have to be careful to avoid some errors that can lead to poor reading of the spring balance or other factors that can affect your experiment. But apart from that, it's a very simple process. So we add 50 grams to the 100 grams and it makes 150. We measure the mass of that in air. So we have 3 Newton. We'll record that and repeat the same procedure. Measure it in water and then immerse it in kerosene and see the value changes. All right, so that's the weight of the mass in air, 3 Newton. Now when it's immersed completely in water, it reduces upthrust. When the upward force acting inside the water has pushed the weight upwards, and now we have 2.65 Newton when immersed in water. Kerosene is going to offer a slightly different push upward in such a way that the value will be slightly different, just like you've observed from the previous masses we've used. So we immerse it in kerosene. Always remember to wipe or clean your masses before you dip it into the different liquids, because you know the other is water and this one is kerosene. So when immersed in kerosene we have 2.7 and in water was 2.65, so a slight difference. And remember, this was for 150 gram mass, so we're going to add 50 more grams and that makes it 200. So we do the same thing, measure 200 in air. Now 200 reads 4 Newton. 4 Newton. So you see the masses just graduate so accurately. So in air is 4 Newton. You can already almost assume that the one in 250 grams will be 5.0 in air. So the 200 grams now fully immersed in water. Fully immersed in water, what will be the measurements? You see it's less than 4 now. It's less than 4. In fact, way lesser than the others was. So we have 3.45 Newton when immersed in water. Remember, when immersed in air it was 4 Newton, or when just measured in air it was 4 Newton. But when it's immersed in water, upthrust pushes a little and then it changes. Now we immerse it in kerosene, it's still upthrust as long as it's a fluid, but slightly different because of the different types of fluid. So we see the value when immersed in kerosene is 3.51 Newton. 3.51 Newton. So we're almost there. That was 200 grams, 4 or 50 grams. So remember, also clean it so that it will be free from the liquid you just left. So that going to the other liquid, it won't add densities to the other liquid. So this is now 250, which is the last. Like we already assumed, 250 is 5 Newton. 5 Newton when measured in air. 250 gram mass when measured in air with our spring balance here gives us 5 Newton. So we're going to, like we've always been doing, measure it when immersed completely in water, and you know that gives us a different value, 4.3. All right, we're going to clean it and then immerse it in kerosene. Immerse it in kerosene like we've always been doing. So we clean it, very importantly. And then we measure it when immersed in kerosene. We can see the value has reduced from the 5 Newton when measured in air, but of course we expected that value to reduce by now because of the upthrust. So we have 3.4 Newton. Okay, remember W1 is the weight of the object in air, W2 is the weight of the object when immersed completely in water, and W3 is the weight of the object when immersed completely in kerosene. So we have to use the values we just obtained to find U. U is W1 minus W2, which is weight of object in air minus weight of object in water. We also analyze V. V is W1 minus W3. That's weight of object in air minus weight of object in kerosene. We analyze all that. You see the values we have there. for U we have 0.13, 0.27, 0.35, 0.55, and 0.70. So there was a little error in the tabulation there. It's supposed to be 4 there, not 3. It should be 4.30. And then this for W, that's 4.30 for W2, and for W3 should be 4.40. So when analyzed, you see we'll have U for when it's 250 grams to be 0.7, but V for 250 grams as W1 minus W3, which is 5.0 minus 4.40, will give us 0.60. Okay, so our table is complete and we are ready to plot a graph. Okay, remember that the values of weight of objects in air, weight of objects in water, and weight of objects in kerosene has already been filled up in the table. So it was just a guide to show us what W1, W2, and W3 was. So let's look at how we can plot our graph and find our slope. So as you can see, the scale I used was 2 cm to 0.1 units on the horizontal axis, and on the vertical axis the same scale, 2 cm to represent 0.1 units because of the values have a high. We're to plot a graph of V against U. So V on the vertical axis as y-axis, and U on the horizontal axis as the x-axis. So I filled in my scores, my values using the scale I provided here, and you can see the points I've plotted. Remember, in physics you are to draw a line of best fit, like I've produced here, and then you use that to find your slope. Remember that slope is change in the vertical minus all over the change in the horizontal. So my vertical is V and the horizontal is U, so change in V all over change in U. Change in V is like I already marked out in the graph, as you can say A minus B according to the shape of my graph, according to the shape of my slope, the triangle of my slope. And I remember that you should use a large triangle when finding slope. Okay, so A minus B, that's change in V, all over B minus C, that's change in U. And A was 0.6 from the point I took, and then B was 0.1, so 0.6 minus 0.1, and I have that 0.5. And then for change in U, B was 0.7, and C is 0.13. So 0.7 minus 0.13, I have 0.57. So I divide 0.5 by 0.57, and I have that my slope is 0.877. Always remember to, in physics, put your answers in 3 decimal places at most, or at least for accuracy. Alright, remember the precautions must be stated in physics exams after practicals. So the precautions I took was that I avoided parallax error in reading spring balance. You see, I had to make sure that it settles and then it's not shaking while I'm recording or when I'm taking my measurements. And then I was sure also that the spring was not shaky. Alright, so also I noted 0 error of spring balance. My spring balance has a knob where I can adjust 0 error, so I had to adjust it before I started to make sure that the pointer marks or points at 0 when the spring balance was not loaded. So number 3, I avoided splashing of liquid. See, I didn't fill it up to the brim so that when I put in or immerse the loads, the liquid splashes out. So I avoided that. Right, I also avoided that the object touching the bottom or sides of the bottle. So I kept adjusting the beaker to make sure that the load, the weight or the masses were immersed at the center of the liquid so that they won't touch the walls of the liquid and also the bottom of the walls of the beaker and also the bottom of the beaker. I avoided that too. And also I cleaned the masses before dipping them into the liquid. You saw that. so that I won't add to the density of the water liquid from the other liquid. Alright, so you can replay this video and practice it and guide yourself, because surely you're going to see this in your examination and you don't want to waste this opportunity. Thank you for watching, and do well to share to other of your friends that would really need this. Thank you.